Alright, this is HC2. This is an honors end of the year review. Alright, first problem is an algebraic equation. We have variables on both sides. So once in a while when you have variables on both sides, you might end up with one of those empty set problems or those identity problems. If you have the same coefficient on both sides of the equation, you might end up with one of those. So let me go ahead and start. I'm going to do leave change opposite to get rid of subtraction. Then I'm going to do distributive property. I get 120 plus negative 48g is equal to 180 plus negative 48g. And I see that I have the same coefficient like we just talked about, so then I have to go check the constants. Since these match, I know they're going to be worth the same. Is 180 worth 120? Because if I took away those sets of g's, I'd end up with the problem 120 is equal to 180, and that is an empty set. You're going to not have a solution, no solution. Number 2 is another algebraic equation with variables on both sides. So let me go ahead and do my leave change opposite. And let me do the distributive property and combine like terms. So on that left hand side I can put 4p and 2p together since they're like terms. And on the right hand side I would do the distributive property and it would become 14p plus 35. Now I have variables on both sides. The coefficients do not match, so I am going to get an answer here. So let me subtract 6p from both sides. Now I'm at 8p plus 35 equals negative 40. Now I'm ready to solve this algebraic equation. So they, of course, multiplied by 8, and then they added 35. So we're going to subtract 35. And we're at 34 there. Those cancel out, and we're left with 8p equals negative 75. Now we divide by 8, and there is our answer. We just need to simplify it. One negative, of course, makes it negative. We'll go in there 9 times with 3 remainders, and so our answer is negative 9 3/8. Number 3 is asking about the length of the hypotenuse of a right triangle. We know that the hypotenuse is the one that is opposite the right angle. So to review, that's the Pythagorean theorem, which is a squared leg squared plus b squared, another leg squared, equals c squared, the hypotenuse squared. So I'd set that up as 11 squared plus 28 squared equals c squared. So that's 121 plus 784, I believe, equals c squared. Combine those, that becomes 905 equals c squared. And remember, how to undo a squared sign is to square root it. Just to review, when you do the square root, you will get a positive and a negative answer. So this actually rounds to 30. So when I do the square root of c squared, I get c, and I get 30. It could be positive or negative, but of course, that negative doesn't make sense in a problem like this. You can't have a length of negative 30. So our answer is 30. The measurement of c would be 30. Number 4 asks for the area of that. Of course, for area, we need to use the two that are at a right angle. So 11 times 28, and then divide by 2, because if I take 11 times 28, I get the area of this rectangle. I want to divide it by 2. So 11 times 28 is, of course, 308, and then divide by 2, and you get 154, and we would label that units squared. 154 units squared. All right. Simplifying this, I like to put a couple fraction lines, even maybe 3 sometimes. We'll see how many we need. And then I like to simplify it one step at a time. So this would be 5 to the second power on top, on the numerator. K to the negative 18th, which I'm going to go ahead and flip it to the bottom as a k to the positive 18th. Remember, that's what negative exponents do. Nothing to do with negative, everything to do with whether they're on the numerator or denominator. And then c to the 12th stays on the top because it's a positive exponent. M to the 16th stays on top because it's a positive exponent. Go to the bottom. That's 5 to the negative 5th. That means it's going to go to the top as a 5 to the 5th. K to the negative 5th, it's going to go to the top as a k to the positive 5th. Negative 2 times negative 5 is a positive 10, so c to the 10th stays on the bottom. And m to the negative 20th moves up to the top as m to the 20th. Now I'm going to combine some stuff. I'm going to go ahead and combine it in a couple steps here. So let me get all my things combined. I have 5 to the 5th and 5 to the 2nd. If I multiply those, I get 5 to the 7th. I have a k to the 5th on top and a k to the 18th on the bottom. I have a c to the 12th on top and a c to the 10th on bottom. And then when I take m to the 20th times m to the 16th, I get m to the 36th. Remember, your rule is if they have the same base, you add the exponents. Now, if you have some on the top and the bottom, like these k's here, right, then they're going to cancel each other out. 5 from the top are going to knock out 5 of those from the bottom, and we'll end up with 13 on the bottom. I have c to the 12th and c to the 10th. So 10 from the bottom are going to knock out 10 from the top, and you're going to end up with c squared on top. You still have an m to the 36th on top, and you still have a 5 to the 7th power on top. And there's your answer, 5 to the 7th, c squared, m to the 36th, over k to the 13th. Number 13 says solve for y. Remember that symbol in between means they're similar, which means they've been grown or shrunk proportionally. So if I want to solve for y, I know I'm going to involve 11 because that's the corresponding side. The other measurement I know is this 13 and this 5. So I'm not going to use the 7 this time. I'd use the 7 to find the bottom of that larger triangle, but don't need it. We'll be focusing on the ones we do need. So let me set this up a couple different ways. I'm going to set it up with a proportion. I could say that 5 has a relationship to 11 because they're in the same triangle, and I would need to keep that consistent, that order consistent. So if I went from this side to this side, I need to do the exact same thing here and go 13 to y. I'd be set up correctly at that point. I could also go between triangles, so I could say 5 is the corresponding side to the 13 in the same way that 11 is the corresponding side to the y. But you'll notice, no matter how you set this up, 11 and 13 are going to be diagonal, and 5 is going to be the one. So we multiply by 13 by 11, and then we divide by 5 to get our answer. And when I do that, I get 28.6. So y is 28.6. Number 14 and 15 go together to write that number as in scientific notation. Right now, the number is 48 million. Remember to write it in scientific notation. We want the first number to be between 1 and 10, so anywhere from 1 to 9.9 repeating. So there's only one way to put your decimal in there, and that's at 4.8 to make it between that range. If you put it here at 0.48, that's too small. If you put it after the 8, it's too big. We want it just right. So 4.8 times 10 to the number of places I need to move the decimal to get it back to where it goes. So remember, I put it right here, and I need to move it back 1, 2, 3, 4, 5, 6, 7 places. So 4.8 times 10 to the 7th power. Next problem says convert y minus 4 equals 3 times the quantity x plus 7 from point slope form to standard form. So this is a linear equation right now that has a slope of 3 and is hitting the point -7, +4. And we want to change that. That's just a little bit of a review on point slope. You don't need to know that, but we're going to change that by doing the distributive property. So I'm going to take 3 times x and get 3x, 3 times 7 and get 21, and now I have y minus 4 equals 3x plus 21. But remember, standard form means I want my x's and y's to be on the left-hand side and my constant to be on the right-hand side. It fits the format ax plus by equals c. So I need to subtract 3x from both sides. That makes it then a -3x plus y, and then I need to add 4 to both sides to get rid of that, and I get 25. Oops, sorry, I put that as an equal sign. So I have -3x plus y equals 25. So number 16 says, what is the a? Well, the a is -3. Number 17 says, so what's the b? There's an understood 1 right there. And what is the c? 25. Number 19, you have a cone, and it's asking about the surface area of that cone. So remember, surface area equals, and you have one base. It's big B, so that stands for area. Plus, since it comes to a point, we want half the perimeter times the slant height. So if I were to set that up to find the base, of course it's a circle, so I'd be doing radius squared pi, which is 11 squared pi, plus 1/2. And how would I find the perimeter of that? Well, remember, the perimeter of the base is what that is. I would want to take 22 times pi to get the circumference, which is the distance around. And then the slant height, remember, is not at a right angle, it's at the slant, so we want to take that times 21. So I'm really typing this in as 11 squared times 3.14 plus 1/2 times 22 times pi times 21. Now, can you do some of it in your head to make your life easier rather than calculating that all. Yeah, half of 22 is 11. Now it's a little bit easier to type in. When I do get all that typed in, I get 1105.28, and that would be units squared, because we're finding out how many squares it takes to cover that. All right, number 20 asks for the slope of the line. Remember, slope of the line you can do by counting, or you could take difference of y over difference of x. I'm going to do it that way, so I'm going to take 9 minus 4. That's the difference of y's in these points, and difference of x, and I have to go in that same order, so 2 minus 3. 9 minus 4 is 5. 2 minus 3 is negative 1, so my slope is negative 5. And just to review how to count that, if you go from either point, doesn't matter which one point you go from, let's see, I'll go the opposite way of what I did it there. So I went 1, 2, 3, 4, 5 down, that would be a negative 5. And then I went 1 right, and that's a positive 1. So again, doesn't matter whether the negative is on the top or the bottom, that makes that answer a negative 5 for your slope. Now, I purposely didn't extend that line to where it would hit the x-axis and y-axis because I wanted you to actually do it algebraically. So here's what we know is we know the slope is negative 5. We don't know the boyfriend, do we? The y-intercept. Now, we could kind of extend it and kind of get about where it's at. We're not sure exactly where it's going to hit up there, but it should hit up there somewhere, right? And I can, of course, extend that down here and find out it's going to hit down here somewhere, but my graphing's not very accurate. Obviously, those lines aren't straight, so I'm going to solve it algebraically. Well, here's what I know is I know what they did. They did this, and I know some of the numbers that they put in. So I'm going to use 2, 9 to solve that. So they got a y of 9 when they applied this slope, negative 5, to an x of 2, and then added some number that we're going to find out. So if I solve this, it turns into 9 equals negative 10 plus b. Now I'm going to add 10 to both sides. When I add 10 to both sides, those cancel out, and I get that 19 equals b. 19 equals b. Well, remember what b is. B is the y-intercept. So we actually just solved for number 21. It's going to hit up here at 19. So obviously my drawing was not very accurate. It should hit at positive 19. That also lets us write the equation. Now we know the entire equation, which is y equals negative 5x plus 19, because it hits the y-axis at 19, has a slope of negative 5. Well, how do we find the x-intercept then? This is one thing that we tend to forget a lot in class, is how do we find the x-intercept? Well, where does it hit the x? It hits the x when y is at, finally, 0. If I talked about this line right here that I'm drawing in right now, that is the line y equals 0. So it's hitting that when y is 0. So let me just substitute in y to be 0. Now I'm going to subtract 19 from both sides. And I'm at negative 19 equals negative 5x. I divide by negative 5. Those cancel out, and you're left with x equals positive 19 fifths, or positive, if I could do math, 3 4 fifths. And so if you look at where it's going to hit right down here at 3 4 fifths.